Okay, this is Unit 6, Applications of the Derivative, Part 2. Our first lesson today is on particle motion. So, example 1.1. A particle moves along a horizontal line so that its position at any time t greater than or equal to 0 is given by s of t equals 2t cubed minus 7t squared plus 4t plus 5, where s is measured in meters and t in seconds. Find the velocity at time t and at t equal 1 second. So, the velocity function is defined to be the derivative of position, because velocity is the rate of change of position. So to find the velocity given the position, I simply take the derivative. So 6t squared minus 14t plus 4. To find the velocity, the instantaneous velocity at 1 second, I simply plug in 1, which will give me 6 plus 4 is 10, minus 14 is a negative 4. And the units, so the units on our position was meters in terms of as a function of seconds. So we're going to do meters per second. It is. So if we want the acceleration, we'll take the derivative of velocity. All right. When is the particle at rest? When is it moving left? And when is it moving right? So what I'm going to do is set this velocity equal to 0, because velocity tells us two things. It tells us the speed, which is the magnitude of velocity, and it tells us the direction of velocity. We're dealing only with linear motion in this class. We are not going to be moving in two directions. We will either move up and down or left and right. You'll see formulas that say S of t, S for position, but you'll also see x of t if it's moving along an x-axis, or y of t if it's moving along a y-axis. Okay, so to find out when it's at rest, we need to solve this. I'm going to divide everything by 2. And then I'm going to factor this. And let's see here. I think I'll do a negative 2 and a negative 1. So I'll set 3t minus 1 equals 0, which gives me t equals 1/3. And this will give me t equals 2. So let's draw a number line. Remember that the AP graders will never grade your number line. They'll only grade your sentence. So we were told that it's for t greater than or equals 0. So I'll indicate that with a bracket like so. At t equals 1/3, our velocity is 0. And at t equals 2, our velocity is also 0. Between 0 and 1/3, this function here is positive. For example, if you plugged in a number very, very small but positive, you would get a negative number times a negative number is a positive number. If I plug in a number like the number 1 in between those, I get 3 minus 1 is 2. That's positive, but 1 minus 2 is negative, so it's negative. A number bigger than 2, such as 5, that would be a positive number times a positive number is a positive value. So we can see that velocity is positive on this region here. So the particle is at rest at t equals 1/3 and t equals 2, because v of 1/3 equals v of 2 is equal to 0. The particle is moving left on the interval from 1/3 to 2. How do I know it's moving left? Because velocity is negative. Now, I could also it could ask me, when is it moving forward, when is it moving backward, but we're just going to say left is the negative direction, right is the positive direction when moving horizontally. They usually make that clear in the problem, but I didn't. And then Lastly, we'll say the particle is moving right on the interval from 2 to infinity, and, also from 0 to 1/3, because v of t is positive. And I kind of ran out of room there, didn't I? But you get the idea. All right, next we're going to find the acceleration at time t and at t equals 1 second. Acceleration is defined to be the rate of change in velocity. So to find the acceleration, when I know the velocity, I simply take the derivative. It's the second derivative of position. So this is 12t minus 14. If I solve this equal to 0, we get 14 over 12, or we could reduce it to 7 over 6, is when the acceleration is equal to 0. All right, so if I plug in a number to the left of 7 over 6, like, oh, we weren't even supposed to do that yet. Dang it. That's in the next question. All right, it's not even in this question at all. Oh, well. Maybe you wanted to know when acceleration equals 0. Just so you know, it's at 7 over 6. But let's find the acceleration at time 1, like it asked. That would be -2. And the units would be meters per second, because per second. So every time, since our y value is meters and our x value, our independent variable, seconds, every time you take the derivative, it becomes per the x coordinate. So when taking the derivative of velocity, my units on y was meters per second, and my units on x was seconds. So now I add another per second. Okay? A 1. It's a of 1. All right, next we're going to find the displacement of the particle between 0 and 3 seconds. So displacement is the change in position. So we'll find S of 3. And I think we'll go ahead and use our calculator on this part. So I'll turn it on. And there's so many different ways you can do this that make your calculator helpful. One of the ways we can do it is we can use the variable s, or if you prefer, we can use we can use the variable t, or we can use the variable x. I will use t. It's one of my quick access letters, as I call it. I don't hit alpha. So I'm going to say 2t cubed minus 7t squared plus 4t plus 5. And then I hit this button to the left of 7, which is such that, and I say what I want to evaluate it at. I want to evaluate it at t equals 3. And so that's 8. Next, I can just change that to a 0, and it evaluates it at 5. Well, I just changed this last number here to 0. Well, you put the such that button. It's to the left of 7. No, we just want the displacement. So it's 3 meters. Well, you have to subtract 8 minus 5. Mm-hmm. For position, yeah. Displacement is the change in position. So what does that mean? At t equals 3, the particle is 3 meters. Do we know the direction? Right, or ahead of where it was at t equals 0. So position, displacement talks about position, and it has a direction. It has if we're moving right or left, a positive displacement is a move to the right. It doesn't tell us anything else about that, though. It doesn't tell us how far it traveled. It doesn't tell us the story of how it got there. It's simply a snapshot at 2 instances of time, and says that at the instance when t equals 3, you happen to be positioned 3 units to the right, in this case meters, 3 meters to the right of where you were at t equals 0. Next, we're going to find the distance traveled by the particle from t equals 0 to t equals 3. So distance is the absolute value of displacement. But we have to be careful about what that means. So the absolute value of displacement curve. So it's, well, I should be more precise. The distance traveled is found by the absolute value of the displacement curve. So if I have a curve like this, and this is my position, I need to find its change in its absolute value. So it's a little bit different, okay? So what we're going to do is we're going to look at where does this particle change direction. Well, it changes direction at 1/3 and at 2. So I need to calculate the absolute value of displacement from 0 to 1/3, then calculate the absolute value of displacement from 1/3 to 2, then find the absolute value of displacement from 2 to 3 and add those up. So we're going to find the absolute value of the displacement from 1/3 to 0. So that's s of 1/3 minus s of 0 plus the displacement from 1/3 to 2. And from part B, we know that on the interval from 0 to 1/3, we were moving in a positive direction. So we expect this displacement to be a positive number. But the displacement from 2 to 1/3 is going to be a negative number because the particle is moving in a negative direction. So that this absolute value here will matter. These two will not. So again, let's go ahead and use our calculator. So just to practice, I know you could plug these in by hand, but 1/3 is 152 over 27 minus s of 0. S of 0 was 5. So 152 over 27 minus 5. And we'll go ahead and use decimal places. 0.630. Instead of 0.629, we'll do 0.630. 3 decimal places. Actually, we really should round to 3 decimal places when we're all done. So I should probably be using 4. In fact, I'm going to do that. Sorry about that. I'll say 0.6296. The rule in the AP Calculus test is always 3 decimal places for your answer. If you give more, that's fine, but they have to be accurate. So we round to 3 decimal places at the end. All right. S of 2 minus S of 1/3. So let's do that. I'll just arrow up and grab that piece again. So that's S of 2. And then this is S of 1/3 again, just in case we want it. So if I do 1 minus that, and then hit diamond enter for a decimal, you'll notice it is negative. But we're taking the absolute value of it. All right, last we'll do S of 3 minus S of 2. So S of 3. And then we'll do 2. So that's 8 minus 1 is 7. Then we'll add all those up together. And get 12.259. And my units for distance is meters. That's the distance that the particle traveled. As you can see, displacement and distance are quite often very different numbers if you ever change direction. In fact, as I always think about it, I can travel far away over the weekend. I could talk to you from this podium on Friday, travel all the way to Austin on the weekend, and come back and talk to you from this podium on Monday and have a displacement of 0. It certainly doesn't mean I didn't do anything, though, right? All right, when is the particle speeding up and when is it slowing down? Speeding up is a tricky concept. Speeding up means that acceleration and velocity are working together. Again, it's not saying when is the velocity increasing. We already found when the velocity was in. We could find when the velocity is increasing. That's simply when acceleration is positive. But when is it speeding up? So, meaning if you're moving to the left and your acceleration is to the left, that means you're moving left at a faster and faster rate. If you're moving right and your acceleration is to the right, that means you're moving right at a faster and faster rate. So both of those things would be speeding up. So what we do is we solve our acceleration function equal to 0. And we actually did that a little ahead of time. And we found that that was at t equals 7 over 6. And then what we're going to do is we're going to draw our velocity timeline. And right below it, our acceleration timeline. And I'll label where these things change. So at 1/3, velocity was positive, but then it switched to negative until 2, and then it switched back to positive. Acceleration was positive. Acceleration was 0 at 7/6. But before that, like if you plug in the number 1 here, you get 12 minus 14 is a negative 2. Before that, it was negative, and then after that, it was positive. So we can see that the particle has a negative velocity and negative acceleration on the interval from 1/3 to 7/6. So the particle is speeding up on the time interval from 1/3 to 7/6 and on the interval from 2 to infinity. Because velocity and acceleration have the same sign. That's all you have to say. They have the same sign. Because they're going in the same direction. Okay? The particle is slowing down everywhere else. So if we think of acceleration as connected to a force, simply multiplying it by mass gives you that force, we could see that when the particle had a positive velocity, there was a tug on it in 0 to 1/3. This tug was slowing it down until it eventually reached a velocity of 0 and then became negative. And then from this interval here, they're working in the same direction, and then something causes this acceleration to change from being no longer is the acceleration negative, the acceleration is now positive. See, this is a situation where acceleration is not constant. And so we see that switch occur here, which then causes this slowdown to occur, which then switches again to now they're going in the same direction again. And then they start speeding up. All right, what I'd like you to do, please, is to you do practice 1.1. All right, let's go over question 1.1. A particle moves along a vertical line with a position defined by y of t is equal to negative tangent t plus 2 secant t for 0 less than or equal to t less than or equal to 1. Find the position of the particle at time t equals pi over 3. Now, for most of this unit, we're going to work with a calculator, but it's anytime we get a chance to practice evaluating trig, I want to do that. So position is simply evaluating at the position function. So we're going to evaluate negative tangent pi over 3 plus 2 secant pi over 3. I highly recommend you have your tangents memorized. Pi over 4 is easy. That's just 1. Tangent of 0 is 0. Tangent of pi over 2 is undefined because it's straight up and down. So the two that are difficult are the pi over 3 angle like that and the pi over 6 angle like that. But remember that there's 1 3 in pi over 3 and there's 2 3s in pi over 6. So that's how I remember it. This tangent is root 3 over 3, 2 3s. This tangent is just root 3. If you can't remember that, then you have to take it back to sine divided by cosine. The over 2's will reduce. So it's simply negative the square root of 3. Secant of pi over 3 is 1 over cosine, so it's just cosine flipped over. The cosine of pi over 3 is a half, so flip it over. 2. And you don't have to simplify radicals. So if you want to call the tangent of pi over 6 1 over root 3, that's fine as well. All right, find the velocity at, oh, I forgot to multiply it by 2. Sorry, it's 2 times secant, so 4. Negative root 3 plus 4. Find the velocity at time t. Velocity is the derivative of position. So this is a negative secant squared t plus 2 secant t tangent t. Is the particle moving forward or backward at time t equals pi over 3? Well, let's evaluate the velocity, because the velocity equation tells you two things. It tells you the speed and the direction. The sign, being positive or negative, will tell me if I'm moving forward or backwards, or in this case, up or down. The secant of pi over 3 is cosine flipped over at pi over 3. The cosine of pi over 3 is a half, so flip it over, you get 2. So negative secant pi over 3 squared is a negative 4. And again, 2 times the secant of pi over 3 is 2. The tangent of pi over 3 is a root 3. So it's a negative 4 plus 4 root 3. And there's no units in this problem, so we don't have to worry about giving units for an answer. Oh, but we're not done yet. We need to figure out if that's positive or negative. Well, 4 root 3 is bigger than 4. So the velocity at pi over 3 is positive. The square root of 3 is a number in between 1 and 2. So you multiply by a number that's bigger than 1 times 4, it becomes a bigger number. So the particle is moving forward. How do I know? Well, because velocity at pi over 3 is positive. When is the particle at rest, moving left or moving right? I simply solved the velocity equation equal to 0. And this is not that hard an equation to solve. We just factor out a secant t. Oh, secant t. I went ahead and factored out a negative because I don't like that negative there. And I'm left with secant t plus 2 tangent t. Oh, that's supposed to be a times. Negative secant squared plus 2 secant t times tangent t. I factor out a negative secant. Oops, that's going to make that a negative. I'm struggling here. So negative secant squared t divided by negative secant t is a positive secant t. And then plus 2 secant tangent becomes minus 2 tangent. Okay, so let's set each factor equal to 0. If I set negative secant t equal to 0, I get no solutions from that because secant never equals 0. Secant is 1 over cosine. The only way that a fraction can equal 0 is if the top equals 0, and 1 is not 0. So all we're left with solving is secant t minus 2 tangent t. Secant is 1 over cosine, so we'll go ahead and make that change. Tangent is sine over cosine. And as you can see, this becomes relatively simple because the cosine is already a common denominator. So 1 minus 2 sine t over cosine t equals 0. We just need to solve 1 minus 2 sine t. So 1 minus 2 sine t equals 0. Gives me sine of t equals 1/2. When does that happen on the interval from 0 to 1? Well, it happens at pi over 6. And pi divided by 6 is definitely less than 1. Because that's a number like 3.1 divided by 6. So that's the only time it's going to happen. The other time is 5 pi over 6, and that is a number much bigger than 1. Because that's 15 divided by 6. Okay, so that's the time when it equals 0. When is it moving left? When is it moving right? I know there's not a lot of room, but we can go ahead and try and figure that out. If I look at the factored form, it's going to be easier, okay? From 0 to pi over 6, secant is positive, so that's a negative times a positive number. Now, tangent starts very small, and secant starts very large. So this is a negative number times a large minus a small, so this is a positive number. So we can say that on the interval from 0 to pi over 6, we must be negative. Oops, and I just made the start of a positive sign. Negative. Now, after that, tangent is going to become very large. So, after pi over 6, but less than 1, this is secant still positive, so it's still a negative number, but it's going to be a negative times a negative, which is a positive. So I'm not going to write it down, but you can see that the particle must be moving left from 0 to pi over 6 and right from pi over 6 to 1, and it was at rest at pi over 6, because the velocity's direction tells us that. Let's find acceleration. The acceleration is the derivative of velocity. So the derivative of velocity here, I got to take the derivative of this, so I need to use the chain rule. So it's a negative 2 secant t times the derivative of secant, which is secant tangent, plus 2 secant tangent t. So the derivative of secant is secant tangent, and then times tangent, because I'm doing the product rule. Got to do the derivative of the first times the second, plus the first times the derivative of second, which is secant squared t. So a whole lot of secants and tangents here, right? All right, is the particle speeding up or slowing down at time pi over 3? So we've got to put a pi over 3 in all this stuff. So that is negative 2 times 2 times 2 times root 3. The secant of pi over 3 is 2. The tangent of pi over 3 is root 3. The secant of pi over 3 is 2. The tangent is root 3. The secant of pi over 3 is 2 times 2 squared. So all we got to do is figure out the sign on that, and I think it's fairly obvious that this is going to be a positive number. So this is a negative 8 root 3. This is 2 times 2 times 3, so that's 4 times 3 is 12. And then that's 2 times 2 is 4, times 4 is 16. So definitely a positive number. So a of pi over 3 is positive. Well, is it speeding up or slowing down? We know it's accelerating. But what was the velocity at pi over 3? Go back up and look and see. Velocity was positive as well. So if velocity is positive and acceleration is positive, we're speeding up. We're speeding up because a of t and v of t, they have the same sign. So it's got a positive velocity, a positive acceleration. It is speeding up. All right, next we're going to use a calculator to find the displacement of the particle from 0 to 1. So this will round to 3 decimals. So I'll go ahead and type in my equation for displacement, which is the position function. So negative tangent t plus 2 secant. Now that's 1 over cosine, but you can also find it under second 5 to go to the math menu, and it's under angle. Oh, no, it's not. It's under trig. Yeah. Then there's secant t. Then I'll say such that t equals 1. Diamond enter to get the answer. And then we'll do diamond enter on the other. So the we're going to do s, oh, it's y, sorry, y of 2 minus y of 1. And you, if you were doing a calculator portion of the AP exam, you would show that and then say, to explain your work, that that value is 0.144. Oh, it's not. 1 and 0. Sorry. Y of 1 minus 1 of 0. That's what I put in my calculator, right? Yeah, it is. Okay. Remember, use your calculator to find the distance traveled by the particle. Well, we know that this particle changes direction at time pi over 6. So we need to find the position from pi over 6 minus y of 0. So we'll find the distance from 0 to pi over 6. And we'll add to that the distance from 1 to pi over 6 in absolute value. So we just, the way you find total distance is you split the problem up everywhere it changes direction, find those displacements, and just make them positive. So again, we can just go right up, arrow up to find your equation. And I'm going to do pi over 6 here. And we'll get 1.732 minus 2. That makes sense that that's a negative number because we got a negative value for velocity. Plus the absolute value of y of 1, I think we found that one earlier, was 2.144. Minus the pi over 6 value was 1.732. So we'll just add those two up together. For a total of getting 0.68 for some reason. That can't be right. Oh, it is 0.68. Yeah, 0.68. We could arrow up and highlight it to see the exact value. But it must be 0.680. Okay, never mind. I was thinking that was wrong, but that's definitely right.